The broadcast is now starting. All attendees are in listen-only mode.
Hey everyone, welcome to our webinar on cybersecurity best practices for ITOT networks. My name is Scott Siphon with Moxa, and I'll be your moderator for the day. I'd also like to introduce our presenter, Rich Wood. Rich is currently the Product Marketing Division Manager here at Moxa and has over 20 years of experience in industrial automation. His work with plant engineers, system integrators, and equipment manufacturers, all in various markets, has allowed him to understand and address the growing list of cybersecurity concerns. Before we get started, if you have any questions throughout the webinar, please submit them in the questions pane, and we'll either try to address them throughout the webinar or during our live Q&A at the end of the presentation. With that said, I think we're ready. Let me send it over to Rich.
All right, thanks, Scott, and thank you everyone for spending your time with us this morning. My name is Rich Wood, as Scott mentioned, and I'll be presenting today. So before we get started, I just wanted to do a brief introduction of Moxa. So Moxa is a manufacturer of industrial communication and networking products. We've been in business for a little over 30 years. And it's been interesting to evolve with the industry from the world of serial to Ethernet to cloud-based connectivity. And data is at the heart of the industrial Internet of Things and ITOT convergence. To make critical data-driven decisions, business first need to capture and collect the data from all sorts of devices from the field before converting it into business information. Data getting from the producers at the bottom of this diagram, from the actual sensors and up to the top with the applications securely and efficiently, is key. And Moxa solutions are all about doing that, from our edge connectivity devices that do connect legacy I/O devices, serial devices, industrial protocol conversion or video, to our industrial computing products that can do protocol conversion and data consolidation directly to the cloud, to our network infrastructure products, providing that core infrastructure to get the plant level data to the SCADA systems and IT systems that use that data. So here's our agenda for this morning. First, we're going to start off with some IT/OT network security trends. Then we're going to talk about some of the cybersecurity standards that are prevalent today. We'll get into some of the top vulnerabilities and gaps, and then talk about some best practices and tips to get you started. So why cybersecurity has become such an issue? So there's two major trends. One is the Internet of Things, which generally is referred to as connecting devices directly to the internet. So that the fact that you're exposing your end devices to the internet presents some security issues. And the second, which is the main focus of today's webinar, is IT/OT convergence. As those IT systems connect with the control systems, that presents a potential security issue on both sides. And so, how do we address that and meet the needs of both parties while accomplishing the business goals? So the Department of Homeland Security says cybersecurity in the U.S. is one of the U.S.'s most important national security priorities. They've established an entire division called ICS-CERT, which stands for Industrial Control System Cyber Emergency Response Team. And they're dedicated to securing industrial control systems. The organization raises awarenesses of latent problems in the industry, as well as publishes safe practices to aid those in the industry. According to data collected by ICS-CERT, they see the critical manufacturing and energy sectors consistently in the top three as far as the number of incidences between 2014 and 2016. The 2017 data should be coming out soon, and I'm sure we'll share that as it comes available to us. In addition, the communications sector is now in the top two, and the communication sectors represent the communication infrastructure of all businesses. security is definitely a concern now in the industrial control systems. So looking at the types of threats reported in the 290 incidences that were reported in 2016, we see that phishing, weak authentication, and network scanning were some of the top threat vectors. But another thing to note was that 28% of the incidents that were reported, there was not enough information to determine the source of the threat. And that's kind of scary. As a result of this growing threat, companies are taking industrial cybersecurity much more seriously. And we're seeing more and more collaboration between the IT departments and OT engineers to reduce their overall risk of a breach. Here's two studies, one by Accenture showing 50% of companies surveyed are considering merging their IT and OT departments in the next 12 months. And that was from last year, so theoretically that could be happening right now. And a similar 2017 study done by the PMMI found that 58% of companies surveyed said their IT and OT departments were already collaborating on cybersecurity. So when looking at the top business concerns for securing industrial control systems, ensuring reliability and availability remains the #1 concern, followed by ensuring health and safety of employees. But the thing to note is that improving security has risen into the top 3 from 8th place just a few years ago. In looking at the top 3 threat vectors, devices and things that cannot protect themselves is a top concern. This would include devices that don't have proper security features, legacy devices that were never designed to be networked, or devices with known vulnerabilities that are not patchable. Another top threat vector is internal or accidental threats, such as an employee plugging a laptop into an open port on the ICS and infecting it. The threat vector that gets the most press, though, is the external hackers or even nation states that have made it into the news in these past few years. So the most important thing to understand about security is that it isn't something that you buy. It's a discipline that's developed over time. The chart shown here from ARC Advisory Group shows a typical maturity model where companies begin with some relatively low-cost methods like device hardening and gaining accurate inventories on connected assets. From there, deploying firewalls and DMZs, as well as implementing access control are typically the next steps. Deploying zones and conduits to develop containment zones, using additional firewalls and whitelisting allowed traffic rounds out the typical security initiatives. From there, getting into security information and event management software or anomaly and breach detection and other software packages are really, they require an investment in full-time security teams in order to manage and implement these systems. So one of the biggest challenges that we hear from customers is the differences in expertise and perspectives between the IT and OT teams as they begin to collaborate on cybersecurity. This chart from ICS CERT covers some of the big differences in perspectives between the two teams. Typically, these differences are revealed as the IT teams attempt to deploy enterprise security best practices on the industrial control systems. Things that are easily identified and automated, such as patch management on the IT side, can be lengthy and laborious processes on the OT side, as patches are often not pushed from the device OEMs, and these patches may actually break production systems. Other examples include technology support life. Enterprise IT equipment typically has a support life of 2 to 3 years and then is upgraded or replaced, whereas OT equipment routinely sees service lives of 10 or 20 years or more. In the IT world, the systems are rather mature that automatically inventory and classify assets, whereas on the OT side, accurate asset inventories are rare, and they often consist of manually updated spreadsheets. So let's talk about kind of the top 3 typical challenges that we see that can be improved on cybersecurity for industrial networks. So first, most legacy industrial network devices lack security features, since the original design for the industrial equipment is for reliability and not for security protection. Secondly, the network design in many legacy industrial network topologies never considered security protection. In many cases, we'll see go into a factory or a plant and see that the control network is one big flat layer 2 network with no segmentation at all. And thirdly, even if you select and enable the security features on the devices and the network is protected and segmented by firewalls, it's still difficult to manage security. A field technician may forget to change the password or enable unsecured connections without notice. So let's dive a little deeper on that first vulnerability, the lack of device security features. When we look at this first challenge, we see that there are many potential security holes which must be considered when working with legacy network equipment. There are many areas of concern around unauthorized access, insecure configuration and password protections, weak password strength, and an inability to log security events. In fact, referring back to one of the earlier slides where 28% of the 2016 incidents, they didn't understand what the threat vector was. In many cases, that's because of that lack of adequate logging of security events. And so without these basic security features, any of the end devices could be a weak point of the network. The second challenge is the lack of secure network design practices. It's common for legacy systems to connect to each other in one flat network without segmentation to limit access to resources. This results in a network penetration in one area, allowing access throughout the whole network. Proper network segmentation can help to isolate a penetration to a single security zone. The third challenge is that even if the network has been secured at installation, problems can show up later down the road. On day 1, the network may have been properly secured, but on day 100, during an expansion project or maintenance event, how can you be sure that it's still secure? Proper operational processes and procedures need to be in place to make sure that security happens over the long run. So the big question we get from a lot of our customers is, where do I start? And that's where standards come in. So this is just a snapshot of a handful of the most common standards that we see customers referencing as they put together their security policies. NIST 800, NERC-CIP for the power industry, ISA 99 or IEC 62443 for industrial control systems, CIS critical security controls, and ISO 27000 series are all some of the ones that we see referenced on a regular basis. And this chart here really just shows a couple of things, is that the scope and intent of these different standards are a little different, but that there is a high degree of overlap. In fact, this chart here, which I'm pretty sure you can't read the detail on this. My intent was really just to show that if you were to cross-reference some of the major standards, that there's a high degree of consistency between them. As far as what their objectives are, there may be some differences in how they recommend you implement those objectives or solutions to those objectives. But really any of those standards that you choose is probably going to steer you down the road of best practices. So for today, I'm going to start with NIST 800 because typically when we engage with both the IT and OT people, the IT people are more familiar with the NIST framework. And that's because the NIST framework really is, it gives you kind of a life cycle approach, a five-step approach, but it really defines what or outcomes that you're looking to achieve. And they're in these 5 areas: identify, protect, detect, respond, and recover. But they also reference what they call informative references, which are other documents and standards which are meant to help you determine the how and how much security is appropriate for your specific environment. And so those informative references may be different for the IT environment than they are for the OT environment. So one of the first questions that most of these standards address is, how much security do I need? And that's a process of really assessing what are the assets you're trying to protect, what is the likelihood that somebody is going to try and break in, and what is the impact of a breach. And depending on what that risk level is, determining an appropriate level of security. So this curve is really just meant to demonstrate a couple of things. The first is, if you look at the red curve, that pretty much matches that earlier slide that showed that maturity model, that typically you're starting with some fairly low-cost initiatives, but those low-cost initiatives, if you look at the orange curve, those typically have the biggest impact on lowering your probability of a breach. And as you add different security elements, the cost and complexity goes up, and the incremental reduction in probability goes down. So typically what people are looking for is that optimal level of security for some minimum cost. So the things we're going to talk about here are some of these things that are on the left-hand side here, where they're fairly low cost things to deploy, but they have a pretty large impact on the overall level of security. So looking back at NIST 800, as we mentioned before, it defines kind of the overall outcomes that you're typically looking for, and it breaks them down into these major function categories and subcategories. And then in this chart here, what this is referencing is, for an industrial control systems, here are the informative references that they list to help you determine how and how much security to implement. And you can see it references ISA 62443, various elements, which is the same as IEC 62443. So this is just meant to give you a little overview of the kind of the roles and scope of the 62443 standard. So you can see at the top, you've got a series of standards that apply to the asset owner. And so that's really about determining, how valuable is what I'm trying to protect, what is the probability of a breach, and what is that overall level of security that's appropriate for me. Then there's the second section down there where it kind of points to the system, applies to the system integrator. And so whoever's designing and deploying your network, here are the best practices for how to design the network or system from a security standpoint. And then the bottom level there really is at the component level. And this is really applicable to component suppliers like Moxa, where it goes as deep as to say, these are the actual features that your products should incorporate from a security standpoint to facilitate your customers designing and implementing networks that will conform to these standards. And so when we talk about security levels, the 62443 standard defines 4 different levels of security, SL1 through SL4. So SL1 is really, these are the things you wanted to deploy to keep from, a careless employee or contractor from inadvertently affecting your systems. So you're really looking at, they're not trying to attack the system. Typically, it was inadvertent, and it's typically internal, either an employee or somebody you've given permission to come in contact with your industrial control system. SL2 is really where we start getting into hackers, and this is the level that we find most people are deploying at this point, with the exception of nuclear power plants and, substations and, assets that are at risk for either organized hacking or, nation state level hacking. But SL2 really, it's protecting you against kind of generic hacking skills, people with fairly low motivation to go specifically at your organization. The means are fairly simple, and the resources are typically, an individual as opposed to an organized group of people trying to attack you. Then SL3 gets a little more complicated. If you feel like there's people that are organizing to try and attack your organization, then maybe SL3 is appropriate. And if the government of North Korea has their sights on you, then maybe SL4 is right for you. So let's dive a little deeper into, starting at the bottom, 62443-4-2. So this is really, we're talking about if you're buying new industrial control communications equipment, what types of security elements should you be looking for and implementing in your systems? So these are 7 different functional requirement areas, and the system requirements of the 3.3 document. The 4.2 document, it specifies how these specific requirement enhancements are called out in each of these areas based on the security level compliance selected, SL1 or through SL4. So let's take a look at where the several risks are in the ICS architecture. So unauthorized access, we need to prevent access to the devices themselves. Unencrypted key or configuration data, configuration files that they typically have sensitive data in them that can be used to hack the system. And so you want to make sure that those files are encrypted and not left in plain text. That goes for when they're being stored or backed up, as well as when they're being transmitted. If somebody's sniffing your network connection, they could easily intercept that data, and if it's sent in plain text, they could use that to hack the system. Incomplete event logs. So how do I know if somebody is trying to get into the system? How do I know where they tried to get into the system? Going back to the 28% of people that didn't have enough information to understand where their attack came from. Again, this is really a function of incomplete event logs. Improper configuration and lack of monitoring. How to make it less prone to error when setting up devices initially, and how to make sure that once those devices are set up properly, that it maintains that way. So jumping into a little deeper, so the main risk here, password. If you log into your bank, and you try to log in 3 or 4 times, it typically will lock you out of the system after so many attempts. They'll also keep you from allowing you to use a simple password like password or ABC123. So just basically setting up the policies around keeping people from gaining unauthorized access to the devices is really the objective here. As I mentioned earlier, connection sniffing. So it's pretty common for some of the older serial devices, even though you have to log in to make changes to them, that information is sent in plain text over the network connections. And if you've got somebody that's sniffing those connections, they can use that data to exploit your system. So by simply securing it with encryption ciphers, that even if they do sniff the connection, they don't gain access to your passwords and user IDs. Same thing for encryption, or excuse me, configuration files. I think just a couple of days ago in the news there was an update on the Russian hacking of U.S. substations, the power grid. So this was an organized group of people. They gained access to several of the areas in the power grid in the U.S. and got to a point where they could actually flip switches. And when they looked at how these people gained access, they gained access by targeting companies that were working with the electric companies and found configuration files in plain text on some of their hard drives, and then used that to access the system. So this is pretty common where you're providing this information to a contractor, they've got it on their laptop, they leave, they completely forget about your organization when they're done with the job and don't necessarily treat your confidential data as sensitive. And so by making sure that those files are encrypted, even if somebody gains access to it, they can't easily get at the useful information. And so finally, auditing security events. As I mentioned before, if you have a breach and you don't know where it came from, it makes it very hard for you to go back and fix that hole in your system. Even if somebody is unsuccessful at gaining access to your system, if you don't know they're trying, the only way you're going to find out is once they're successful. And so making sure that you're logging security-related network events, storing them on either a trap or syslog server, somewhere where you can do an audit later on in the process. So jumping back to the standard, now that we've discussed some of the device level concerns, let's look at the next part of this, the system level. So central to all cybersecurity standards is the need for a security lifecycle and process. This is a continual assessment of threats and system design. But cybersecurity also involves the segmentation of network architecture into logical zones of devices with similar security requirements. Communication between zones must be over a network link, which was referred to as a conduit. The interfaces of the conduit are typically terminated by a firewall device, which defines the zone-to-zone interaction. Only specific traffic is allowed to flow across these boundaries. Applications which use these conduits must be examined and their network requirements identified so that they can operate in the secure environment. Interactions between different zones is limited so that levels 2 and 1 can communicate directly, but 3 cannot directly access 1. And no access level from 4 to level 3 or below. These need to control these interactions between zones and limit which protocols can be used over the conduits. This brings the need for an industrial firewall. A dedicated firewall is the most common method of restricting access from zone to zone, as well as providing upper layer protection through deep packet inspection. You can see here that there are different types of firewall devices available from Moxa. These are the EDR series. The performance and features vary based on different models. There's also a need to provide secure remote access to industrial control systems. This drives the need for VPN capabilities to provide encryption to the communications which travel over public networks or even private cellular networks. There are different technologies used depending on the application. You can also see that the number of VPN connections vary based on the device selected as well. So you may only need a lower performance device at a remote site, but need a much higher performing device at the headquarters site to support all the remote site connections. So let's look at a couple of things about industrial firewalls. And one of the questions I get pretty frequently is what's the difference between an enterprise firewall and an industrial firewall? So aside from the physical differences as far as one being designed to operate in a nice air-conditioned server room versus another that's designed to operate out in the harsh environments of the factory floor, the types of traffic that they're filtering are often very different. And the skill level of the people using these devices also varies, whereas IT people typically have somebody that understands the complexities of developing fairly complex firewall rules. On the OT side, people understand the control traffic that they're used to using, but they may not know the specific TCP or UDP ports associated with those. So in an industrial firewall, typically we try to make it a little easier for people to implement by having these quick automation profiles built in, so that if I'm running Ethernet IP over a specific segment and I know I need that type of traffic to be whitelisted, I can just go into the drop down here and activate Ethernet IP as the type of traffic that's allowed. So the second is, we talked about devices that are not protectable on their own. Well, there's also some protocols that were designed long before cybersecurity was even an issue, and Modbus is a good example. I think Modbus originally, somewhere around 1970, before the internet was the thing. So they don't have the typical design for security, and that means you need to dive into the application layer data within the packets in order to find out if there's malicious code in there. A good example would be Modbus giving a SCADA system or an HMI monitor access to a production line will give it both read and write access without deep packet inspection. And often that can lead to trouble. Another technology that we're seeing more and more being used at the edge is access control lists. So simple filtering of criteria for ingress and egress traffic, such as, on a particular port, I want to allow traffic from certain IP addresses. I want to allow traffic to certain IP addresses or MAC addresses. I want to allow certain IP protocols, or I want to allow certain Ethernet types. So we're seeing more and more of this, and in many cases we've heard this referred to as kind of the poor man's firewall. So that brings us to a little case study. So this was a steel mill in Germany, and they actually had a fire on one of their production lines because they had an HMI that was set up through Modbus to monitor several production lines, and the operator inadvertently turned off one of the cooling fans on one of the production lines, and that caused the steel mill to catch fire. So after the fact, they were looking for a way to keep this from happening again, and by simply deploying some industrial firewalls and using deep packet inspection to only allow read access to those production lines, they eliminated the possibility of that happening again. So the final area we're going to dive into a little bit is the security management system within the 62443 framework. So one of the tools that we see as kind of foundational on the industrial control side is a good industrial network management package. This checks a lot of devices. You know, in this case, as we mentioned earlier, a lot of people, they'll get a spreadsheet from their integrator or the machine OEM that gives them the devices on the network. And that may or may not be updated over time as upgrades are done or maintenance is done. So we find that the fact that these programs can automatically scan the network and identify all of the devices, potentially even some devices that aren't supposed to be connected, is a great first step. They also often allow you some fast, easy way to deploy and verify security policy has been enforced in the devices. They give you visualized network topology and device status, real-time alerts and events logging, and they'll help you provide that baseline network configuration so that should you have a problem, you have at least a snapshot of what the network was supposed to look like, as well as the ability to schedule backups should you have a problem. They often also include troubleshooting tools to aid in network recovery, and many of them also provide northbound APIs to connect and share information with the IT systems, such as, IT may have their own network management system or security information and management system. So here's kind of a snapshot of Moxa's MX view. This is a new security view that was released last year. You can see color coding here. We've defined a couple of security policies: high, medium, basic, and open. So high in this case is 62443 level 2. Medium is 62443 level 1. Basic would be, what I believe it's what Cisco defines as kind of basic level security on network devices. And open means either we don't know or the device has not been configured. This little chart here gives you an idea of what are the elements that are addressed in each of those levels. And the color coding tells you how each device has been configured currently. This is coupled with Security Wizard that allows you to quickly step through and say one of these devices is at the medium level and you want to bring it to high. You can run that Security Wizard. It'll show you exactly the steps you need to take to get that up to the policy you've defined. And as I mentioned, ongoing security management throughout the entire network lifecycle is critical. Even if your IT department comes in or an integrator comes in and does a great job of getting you up to current standard, if you're not monitoring to make sure that you're maintaining that level of security and you're not monitoring for intrusions and other security events, it's going to make it really difficult to ensure ongoing security. So with that, I'll just do a quick recap. The three main things that we're recommending as your starting point for cybersecurity. First is, reinforce the security on the devices that you have, or if you're looking to acquire new devices, here's some things to look for as you're shopping. Make sure that, pick a standard, pick the level of security that's appropriate for you, and then make sure the components you're buying can have the features to support those policies. Second is that network design, secure zones and conduits, segmenting that network so that if somebody breaches one part of the network, you minimize their access to the rest of the network. And third, using a visualization tool to deploy those security policies and monitor them over time. So with that, that's the end of my presentation here. I'd like to open things up for the Q&A session.
Yeah, thanks, Rich. And we actually got a lot of good questions, so thanks for those that submitted those. We have a few minutes left to address some of these questions, so we'll dive into those and get through as many as possible. Okay, so Rich, the first question, is there a product certification I can look for to know that the devices I am buying have the same features I need?
Yeah, great question. So there are a few certifications that are starting to show up, like ISA Secure, that will certify products to the IEC 62443 standards. Another one is Cybersecurity Assurance from UL, but right now adoption is really low. And the last time I checked, there were really no industrial switch or router companies with certified products. Moxa is investigating third-party certification, but we have not decided on a lab or a certification at this point, and I think that's probably true for most of the major manufacturers.
Great, thank you, Rich. So next question, you mentioned IEC 62443 compliant products. What about NERC SIP compliance?
Okay, so we must have somebody from the power substation market. So yeah, NERC SIP is actually law here in the United States for, that's from the North American Electric Regulatory Commission, I believe is the name. And so for products, for Moxa's products, we have a series of products specific to power substation or related to power substation applications. And for those, we do supply NERC SIP compliance tables. And I think that's pretty standard in the industry. If you're selling products to support networks within substations that you know, we understand that you're obligated to conform to those standards, and we do what we can to help you comply.
Great. Okay, so next question. What about intrusion detection and prevention systems? Are they worth looking at?
Sure. Yeah. If you've already done a lot of the fundamentals that we've talked about today, then that might be a likely next step for your organization. But as I mentioned in the earlier slides, you know, cybersecurity is an ongoing process of building capabilities. So if you haven't done the blocking and tackling, the basic things that we've talked about today, then you know, you might be premature for you. But Moxa is in the process of evaluating and developing partnerships with intrusion detection systems and intrusion protection system vendors.
Okay, thank you. So next question we have is how can I find out if the devices I'm using have any vulnerabilities?
That's a great question. So I think the best place is to check with the manufacturers. They would have the most updated information about their products. But I think a great source for ongoing monitoring is the ICS CERT website. They list known vulnerabilities, and they work directly with manufacturers like Moxa to communicate patches to these vulnerabilities. And you can actually sign up for alerts on their website. If you know what manufacturers' products you're using, you can sign up for alerts related to those manufacturers. And anytime a vulnerability is found, they'll send you an email, and you can look into what the patch available is.
Okay, looking at the time, looks like we have time for one more question. So the last question we'll address, you showed a snapshot of a table that referenced IEC 62443 standards mapped to the NIST 800 framework. Can you share that or tell me where to get it?
Yeah, sure. So I got it from NIST. I believe I got it from their website. Might have been buried a little bit. I knew exactly what I was looking for, but if you can't find it there, feel free to reach out to me directly, and I'll send you what I have. So my email address is richard.wood@moxa.com, and I'd be happy to share what I have with you.
Okay, thank you, Rich. Thanks for your time today. Unfortunately, that's actually all the time we have for questions, so we're going to have to wrap things up. If we missed your question or if you want guidance on a specific issue or situation, please feel free to reach out to us directly at usa@moxa.com. One last note, you'll see a survey pop up after this broadcast. If you could please take just a few more minutes to complete the survey, as we're always looking for ways to improve future webinars. Thanks again to everyone for joining us. Until next time, enjoy the rest of your day.